So, principal component analysis part 2. Uh, just go into more depth about in what language I have experience in using this and in what application. Um, so this is this is the code that was written for one of my assignments. This is Bioinformatics, and part of it is just organizing the data through metadata was the first step. It started the assignment, and then fixing it to be even, and then log transferring it. So in clustering is the main thing that we use this in. What we did after we wrangled the data is make a hierarchical clustering. This is shown in the highlighted part. We used the technique of average. Here we did single value decomposition. On the log ratios, right? Not too. Then we did principal component analysis, treating all the features of the yeast, because yeast was what was the data, and it was yeast, scientist, year. So we treat each of those features as variables in this principal component analysis, and we use this code. Then we visually see what's this, principal component analysis is, because that's the assignment. Now, instead of going from principal component analysis to plotting, you could run maybe an additional algorithm on the principal component analysis and on the numerics of it and the weights, and to see if the next thing is to identify in a visual project what type of animal, or object identification would be another level above this, above PCA, principal component analysis. This is all just a homework assignment that we have done. Rank invariant, it's useful. This is all bioinformatics, so this is just an example trying to use my knowledge that I was given in this class and apply it to optics. So here's another more concise version of what we just saw of the hierarchical clustering. And this one uses the distance between square root. Here's a 2D example. The first part's a 2D example. And this is why it's easier, because it's actually just using like a matrix with the differences. And this is how you merge hierarchical clustering. This is then applied to this for the more detailed analysis. I think this was given as an example. So I was checking this out. So this is a biometric system classification using PCA. So also, I guess if you're new to GitHub, this is just basically how you use it. Pretty intuitive. I know that it's like a skill that is taught nowadays, but maybe I just don't get the finer details of it. Open up the thing. It's used as a collaborative platform. Okay, guys writing in Python, not an expert. I'm not an expert in Python. I barely use it, but it's pretty similar to the other languages. He's getting from the packages all these different, you know, packages, libraries, linear model, linear regression. You need a decision tree classifier, confusion matrix, the plotting. Okay. So this code is to classify, system classification. Okay. So he used it. This is the Python version. On the main, because that was the function I just showed you on the main code. He is computing PCA with linear regression and cross-validation. So there's like 5 different ways to compute PCA. One is taught that uses covariance. Another one that was taught is singular value decomposition. So if you're using covariance instead, let me show you. Find the covariance matrix right there. I think you can derive it now through this, as you can see in this. The expectations, covariance, stuff we learn, everyday stuff. And I thought if you don't have covariance, you'd have to do an iterative computation. And this shows you the pseudocode to do that.